Thank you, everybody, for joining. We really appreciate it, especially right after the keynote joining us here. So we're going to go into a lot more depth about cloud AI. You heard a lot in the keynote this morning about the kinds of things that we're doing with AI, and I'm going to go into a lot more depth about how we're approaching this, how Google overall has been approaching AI, how our products are built, and then also how do we approach customer problems? What are customers doing with AI right now, and what's some of the advice that we typically give to customers? We're also going to show you some demos of the things that we've built. My name is Rajan Sheth, and I'm the Director of Product Management for Cloud AI. And we're a relatively new team within Cloud that has been doing a lot to bring the fruits of Google's AI to you. So we talk about Google as an AI company, and we actually really mean it. It's more than just a marketing message. And this is a little bit of proof of that. This is the number of project directories that have AI models built into it within Google. And you can see over the course of just a few years, it's gone from a very small number to almost 7,500 directories that have AI built into it. And this is only increasing. We've gone from just a few products at Google having AI built into it to almost nearly every single product at Google has AI in it in one form or another. And we're realizing this is a revolutionary technology that's kind of the underpinnings of computing and will be for the next 30 years. But one of the problems that we hit is, as we start to bring these technologies to others, is essentially this. This is a skills gap that we're hitting, which is that right now there's on the order of tens of thousands of people in the world that can build a deep learning model to especially do things like analyze unstructured data and be able to create predictions very well. There are on the order probably more like 2 million data scientists that are out there. And for example, we have Kaggle, which is one of the biggest communities of data scientists that's out there. But there are 21 million developers out there. And our goal is, how do we make AI easy enough such that we can get it to those 21 million developers and they can build it into their applications. And so the goal of our group is to democratize AI by making it easy, fast, and useful for our customers and partners. And to dig into those words a little bit, easy, we want to make it easy for the novice, but we also want to make it easy for the expert to do very, very sophisticated things. We want Google Cloud to be the fastest place that you run AI, and we also want to really make it useful. And I think that's a really key word. There are a lot of things that AI can do that are cool, but what we really want to focus on with you is, how do we have it impact your business? How do we actually have it give you return on investment and make it so that it's something that is very useful to your business and can transform your business? So a few of the kinds of things that we're seeing our customers do with this. One is around personalized customer interactions. You can really kind of develop a much closer relationship with your customer using AI. Ocado is a good example of this, and I'll talk a little bit more about Ocado a little bit later. But one interesting thing that they're doing is they're using our natural language APIs to look at emails that are coming in and assess the sentiment of that email. And if it's an angry email, they'll push it down a different queue than if it's not. And so these kinds of things make sure that customers get the right level of service. Efficiency and agility. We're seeing this in areas all the way from things like demand forecasting and inventory optimization, all the way through to how we run our own data centers. And so there are many things you can do to optimize your processes, all the way to doing things that are predictive, things like predictive maintenance, for example. Spotting patterns. AI is better at spotting patterns in many cases than humans. Rolls-Royce Marine is a great example of this, where they're using this to spot patterns or spot obstacles in a waterway so that they can figure out how to guide their ships. And then the last thing is adding structure to unstructured data. Box is a great example of this, where they've integrated in our Vision API. And now what you can do is make sense out of the images that you have in your Box repository. And this is an area where I think AI is going to get more and more and more advanced, and also more useful, because over 90% of the data within an average company is unstructured data. And that's the kind of thing that we would be able to really help with. In terms of Google, though, the biggest things that we can really provide is, of course, scale with Google Cloud. We have unparalleled scale. But then the other thing is speed. And I want to dig into this point a little bit, because one thing that we realized as a company a few years ago is that we really needed to rethink our data center architecture to really look at how it can be most useful for AI. We were realizing, for example, if everybody picked up their Android phone and said, "Hey, Google," and said something, that would sap all of our data center capacity. And so that's where we started innovating all the way to the silicon level to make AI much, much faster. Quality. AI really depends on high-quality models. And we have models that we've developed over the course of a decade or more in areas like translation and vision and speech that really bring the best to businesses. And then customization. AI is a mass customization problem. Even if you have two customers that have similar problems, likely they're going to need to customize to solve it in slightly different ways. And especially with deep learning, customizing a deep learning model is not very easy. And so what we want to do is make that a lot easier. You saw that this morning with Otto ML, and we're going to show you this more. But then also what we're doing is working with customers and then working directly with partners to figure out how we can meet deeper needs. So this is how we think about the stack of products that we have to really address this need. At the underlying part of it is our data stack, with things like BigQuery, with all of our data ingestion tools, with all of our data processing tools that we have, because really all of this starts with your data. On top of that, we have 3 levels of AI products. We have our platform, such that if you're building your own model, you can bring it to Google Cloud and we'll scale it for you. The second thing is our building blocks. And building blocks are where we're bringing the best of Google's AI to you as services. And so we've taken, for example, some of the best models that we have from things like Google Photos or places like YouTube or things like you saw in our Smart Reply product. And we're bringing those as APIs in vision and natural language and speech and various others for you. And then lastly is solutions. We want to get to the point of solving specific types of customer problems. I'm going to go into the first couple of the ones we're releasing here at Next and kind of how we're going to think about this going forward. Now, what I'm also realizing is there are 4 different types of users on top of this. There are businesses who are thinking about their business problems, and that's really where we want to address it with these solutions and partners. There are data scientists, and so we're integrating these things into Kaggle to make it such that data scientists and the large community of data scientists have access to this. There are developers, and we have some of the largest communities of developers with Android that we're integrating this into. And then there's the end user. Anyone that works with data in a spreadsheet, in my mind, can be a data scientist. And that's where we want to integrate it such that anyone that's using a spreadsheet can use machine learning. So looking at the building blocks, there are 3 big areas that we've been focusing on, which are kind of the hallmarks of where Google has focused a lot of our attention, which is sight, language, and conversation. With sight, we have APIs around vision and video intelligence, where you can send a picture or a video to us, and then we will be able to tell you more about that image, and we'll be able to give you metadata around it and a variety of other things. We have language with translation and natural language to do some of the best translation in the business, and then also take an arbitrary piece of text and get metadata and sentiment out of that. And then we have conversation, and that starts with things like our speech-to-text and text-to-speech, but then Dialogflow, which is bringing a lot of the best of Google Assistant into an SDK that you can use to create your own assistant or create your own dialogue. One of the things we're now building on top of that is Otto ML into all of these. And really kind of this goes to that mass customization problem. How can you take some of the things that we've done, but then customize it to your particular problem? And so let me talk a little bit about Otto ML. So the way we've tried to solve this with Otto ML is to have machine learning that can create machine learning for your problem and can create a custom machine learning model. And all you have to do is use it on top of a data set that you put into Google Cloud. We will run a model on top of that to try to find a machine learning model that matches it and matches it with high accuracy. And then we'll iterate over and over and over and over again until we get to high accuracy. And then we'll deploy it instantly on Google Cloud and give you the ability to just have an API by which you can access it. And it makes it very, very easy to go through the entire machine learning process. And then at the end, you can actually look at it and analyze it and refine it based on the data and based on the accuracy that you see from that. So to show you exactly how this looks, I'm going to invite Philippe up on stage, who's going to demo this with Otto ML Vision.
Thank you, Rajan. So good morning, everyone. My name is Philippe Poutenet. I'm the product marketing lead for Cloud AI. Just a little bit of context before I get into this demo. As you might have noticed from my accent of my name, I'm French. And like every French person, I'm pretty passionate about cheese. And something came to me when I moved to the US about 10 years ago is it seems like everybody in the US every time they see a big, round, white cheese, it ends up being a brie. But when you know your cheese, you know that not every white, round cheese is not a brie. You can have a brie, you can have a camembert, you can have other type of cheeses. Anyway, fast forward to 2018. Finally, AI is at a point where I can finally build a tool to basically explain all my friends what is the difference between all those white, round cheeses. So here comes Otto ML to the rescue. So to create a model here in Otto ML, it's actually very easy. The first thing you have to do here is to add your images. You can basically upload images directly from your computer or select some kind of file directly from cloud storage. Here for that specific exercise, I built it very quickly. I just uploaded a few hundred images directly from my computer that I had. So I ended up with about 151 images that you can see here. And the second thing that I need to do here is to label all my images. So how do I do that? Here you can see add label. So I just create all the type of cheeses that I want to label. So here I've got my camembert, my blue cheese, brie, cheddar. And to label them, it's really, really simple. Just hover over, click the one that I want to label, go to the label category drop down, and here it is. So I just label all my images. So for that specific exercise, I did my homework. I labeled a few images. And before I go and move on to train my model, if the internet, here it is. Oops. That's why we do live demo, because we don't cheat on them. Oh, wow. I'm just going to restart my Wi-Fi. Hopefully, it's going to work out. And I'll be able to connect. Sorry about that, guys. Here it is. I should be on. The internet is down? It is down. Do we have a wired?
OK, so while Philippe's doing that, what you're seeing here is with cheese, obviously. But then the really interesting thing here is that you can apply this to an arbitrary problem. And one of the things that we've seen people really struggle with is product identification. A great example of that is, for example, Disney was one of the customers we launched with. And with what they were doing, they were trying to find all products that had a certain Disney character on it. How many of you guys have children that really like Disney characters? Several of you out in the audience. I have a 5-year-old who loves Lightning McQueen. And he has an insatiable appetite for everything Lightning McQueen. And so what they can do is now actually use something like this to train custom models to find Disney characters. OK, looks like we're back up and running.
Thank you very much. Sorry about that. I've labeled all my images. Thank you very much, Rajan. And the first thing that I need to do is just to make sure I've got enough images to train my model. What Otto ML tells me here is I need to have at least 100 images assigned, for each label to have a pretty good, qualitative model. So here I can see that in camembert and brie and blue, and for the one that actually matters, I actually have enough images. So I think the next step here is really moving to the training model. So all I have to do here is move to the next step and just click on train. So I've trained a few, models ahead of time. But really, if you want to train a brand new model, all you have to do is click on this, call to action here. So this is the model that I train. It basically shows me all my stats. I've analyzed 731 images with my precision and my recall. If I want to see more data around my model, I click the full evaluation, and I can, for example, see my confusion matrix, where I can exactly see which label were the most often confused for each specific label. I can click on each of them if I want to get a little bit more information on how to make any type of modification on my model. So that's really kind of like, if you think about, I haven't written any line of code at all, and any type of machine learning knowledge that I know at this point is just to be able to read the statistics that are specifically on the screen. So I've got a model. Everything checks out pretty good. So I think it's time I'm going to go test my model. So to test my model, I just have a function inside Cloud2ML to just upload a few images and basically look at a few cheeses. So I'm just going to pull a few images specifically for this demo that were not in my training model. And hopefully, the model will be able to give me some kind of prediction if the internet wants to work. And here it is. So this person is quite enjoying a brie, looks like, at 72%. And here, we kind of like, I wanted to trick the model. I'm like, OK, I'm going to give you some other round cheese inside this model, but I'm going to give you a big brie in the middle to see if the model gets it. And at 65%, the model is capable of telling me that this is actually a brie. And another image of camembert that gets it at 99%. So that's really how easy it is to train and to get a small prediction. If you want to now implement your model, all you have to do, we give you an API, is basically querying this API. So taking a step back here and being a little bit more serious here, we use something funny for cheeses. But if you think about all the application that can be made with this, from an enterprise standpoint, think about tires and thread usage, or nails and screws, and any type of things where people have really a hard time building their own model for industry-specific use case, and sometimes just don't have data science expertise. This is a tool where pretty much anybody can actually use as of today. So thank you very much, and turning it back to Rajan.
So going beyond Otto ML, how do you actually build models on Google Cloud, and then how do you scale them? So for this, we're building out our Google Cloud AI platform. We've started this with Cloud ML Engine. And Cloud ML Engine lets you take a model and then be able to upload it to Google Cloud and then scale it. It also has things like hyperparameter tuning and a variety of other things to be able to make it easy to manage your model. We're doing a variety of things here to advance this, particularly here at Next. So you have fast prototyping, so you can be able to use BigQuery to be able to start to work with your data. You have the easy model management we've talked about. But then a couple of things we're introducing here is multi-framework, having this actually extend to multiple frameworks, and then easy hybrid deployment. And I'll talk a little bit more about that. So our goals here with the platform is to make it so that you can easily train a model, but you can also then build it into a production workflow and make it so that you can productionize models. We've seen a lot of times the drop-off between trained models and productionized models is very, very steep, and so we want to make that easy. But we're also working on ways to make it easier to share your work with others and then also deploy anywhere. So a couple of the things that we're adding here that you're going to see launched here at Next. One is support for scikit-learn and XGBoost. Previously, Cloud ML Engine supported TensorFlow, but we're extending the frameworks. And these are two of the frameworks that we've heard from many of our customers that you really want and that you're using within your enterprise today. And so if you have a model that was built on scikit-learn and XGBoost, you can now run prediction for that in the cloud. The second thing is CubeFlow. So CubeFlow is an open source project that we started in December of last year, and it's really kind of gained a lot of momentum. And this is machine learning built on top of Kubernetes, and making it so that not only can you run machine learning on top of Kubernetes and flex it to however you want, but you can move it between on-premise and cloud. And to dig into that, what it gives you is out-of-the-box support for top frameworks. It gives you Kubernetes underneath it to manage the dependencies and the resources. And it gives you a whole library of machine learning services on top of that. And as you saw in the keynote this morning, we have now the ability to run Kubernetes and manage Kubernetes on-prem. This benefits from all of that. And so now you can run a machine learning workload and then be able to easily manage moving it back and forth from here to the from on-prem to the cloud and back. We see a lot of customers, for example, want to do prediction on the edge, and this lets you do that. We see customers that want to train in their data centers and then move prediction into the cloud, and this lets you do that as well. So what if you could hire 1 million data scientists? And this seems like a bit of a joke, but in reality, it actually is real. This is where we think Kaggle can really come in. So we acquired Kaggle last year, and Kaggle is a community of data scientists. When we acquired it, it was nearly about 1 million data scientists, or less than 1 million data scientists, and now it's almost at 2 million data scientists that are part of the Kaggle community. And these are people that are able to build a community by which they can share information with each other and share techniques with each other. A couple of the interesting things with Kaggle are there are lots and lots and lots of public data sets that you can use here to be able to make your models better. There are lots of sample models and sample notebooks that you can utilize there. And then Kaggle kernels, we've been developing that out and seeing huge growth in Kaggle kernels. And so it's really moving beyond competitions to a place that you can go to do data science. And we've now started to integrate, for example, some of the public data sets from BigQuery and various other things into this to make the tools in Kaggle better and better. The last part of this on the platform is how do we make this fast? And really, this is where we are expanding the frontier of performance with what we're doing with TPUs. So earlier this year, we launched Cloud TPU v2 in beta, and you can see that all the way over on the left-hand side. And we've seen some pretty amazing results with customers who've been able to run an order of magnitude faster than they were before. We're announcing Cloud TPU v2 pods in alpha now as well, and so this is a bunch of TPUs strung together to effectively create a supercomputer with enormous performance advantages. And you can see, we can get to 11.5 petaflops with this. And so for very, very large machine learning tasks, this is something that gives you unparalleled performance. And this is something that we use a lot within Google. And we're also releasing Cloud TPU v3, which is the same configuration as what we had with v2, but much faster. You can see the increase in teraflops with Cloud TPU v3. And so this is something that's just going to keep getting better and better and better. And so if you're developing things on TensorFlow, this is a way to make that make that a lot faster on Google's infrastructure. There are particular types of models this works really well for. So for example, things around image recognition, things around translation, this works really well for. And we're creating more and more and more support for more models and more of TensorFlow, such that the more that you write within TensorFlow, the more that we can speed it up. So the last part of this is how do we actually bring it to the business problem? One of the key things that we're realizing with AI is that it's only valuable if you can actually work it into the workflow of an average enterprise. And so that's what we're really trying to figure out is how can we combine the AI tools and the AI expertise we have with an enterprise's data and their workflow to make it so that we can build a powerful solution for a particular business problem. And there are two that we're going to be announcing here at Next this week. The first is Cloud Contact Center AI. Which is essentially integrating a lot of our great conversation and natural language technologies into the products of contact center partners. So we talked about Dialogflow, which is our conversation engine. We've made some significant enhancements to Dialogflow such that you can just use this off the shelf to not only create chatbots now, but also tie into phone lines. So we have a big release that's happening today for tying Dialogflow into a phone number. So you can call up Dialogflow and be able to chat with a voice in that way. And so for example, a small and medium business, it's a very easy way to actually answer a phone call. we have really amazing technology on the back end for natural language processing. And we're tying it now all together with contact center partners who are going to be able to bring this to customers and tie this together with the customer, the automated system, and the agent, and to make the whole customer experience even better. We have partners such as, for example, Genesys and Cisco and a variety of others that are now part of this program and making it such that pretty much any of the contact center products that you're using out there will hopefully have this as a part of it. Another thing that we're doing is we're partnering with Iron Mountain, and Iron Mountain is the trusted guardian for about 95% of the Fortune 1000. And so we're tying a lot of our document understanding technologies into Iron Mountain, so that if you have documents in Iron Mountain, you're going to be able to utilize our natural language understanding technologies within it. And this is really just the beginning. And so back to kind of how we think of this product line in these three areas, I think what you're going to continue to see is we want to get to the point where AutoML is available for all of the building blocks that you see in the middle there. And then we're working with our customers to figure out more and more solutions and how we, along with our partners, can actually solve their problems. So I want to give you a few customer examples and then talk a little bit about how we approach customers and the customer problem. Ocado is a great example. Ocado is one of the world's largest online-only grocers in the UK. And they've done some amazing things with this to be able to do everything from control inventory and predict demand all the way to making their contact center more efficient. And using a variety of the products that we have, they've been able to do analytics over more than 100 terabytes of data to be able to predict demand and control their inventory. They have 4x faster response time to urgent customer replies by the machine learning I was talking about earlier, where they can identify an urgent request from a customer and be able to address it immediately. They have a 7% increase in contact center efficiency as a result of this, and an 80x faster delivery of analytics results in 33% lower cost. And so you can see how they've really infused machine learning into their business and are really building on top of this to make their business better and better and give themselves a competitive advantage. Kewpie is another great example of this, and they're using this to identify visual anomalies in food. And they have a ton of food that they have to examine, and this is making the process a lot easier. So they have 4 to 5 tons of produce that are processed daily with over 400 different types of ingredients. And by using visual inspection and anomaly detection, they've been able to increase their production at scale and the speed and precision of these results. And so they've made their process much more efficient as a result of this. Vice had a problem that is probably anybody that is in the content industry can relate to, or in the media industry can relate to, that they want to be able to take an article and then address it to anybody in any language. And so they're using Google Translate. And Translate has turned out to be one of our most popular products, because very quickly you can take anything from a term to a phrase to an article and be able to translate that into many different languages. And so in this case, they're able to take articles that they have and translate to 18 different languages and be able to make it so that they can extend to a much wider base of readers all across the world. In the Global Fishing Watch, and so they're using machine learning to be able to power high-scale data exploration, supporting research about sustainable global fishing, and using a variety of our tools to be able to do that. They have about 400 billion location messages within this, and they've been able to automate the analysis and visualization on a global scale using a variety of the products, both things like BigQuery all the way through to our machine learning products. So one of the big things that we get asked a lot is, what's advice that we would give to our customers about machine learning and how they should be approaching machine learning? We're kind of finding people a little bit at extremes. On one end, people have been doing things like predictive analytics for quite a while and are used to that. But then they're looking at a lot of the technologies that are there for more advanced machine learning, and it looks very daunting. You see things like the self-driving car, and you kind of think like, that's the kind of thing that you want to go build. But we have a few steps of advice that we've really told customers about how can you take it from something that seems very daunting to something that is very practical and can actually solve a business problem. So the first thing is to start simple. And there are lots of simple ways to get started that can have very, very high impact. And an example of that, of what we've seen here at Google, is suggested search. This was actually done by one engineer way back probably about 12 years ago. It was actually done on Google Labs, back when we had Google Labs, where an engineer could try something out and put that out to the public and see how people react to this. And they built a clustering model to be able to figure out, as soon as you're typing something, what they should be showing next. It is amazing. I can't even think of what Google Search would be without that. And especially one thing that engineer probably hadn't anticipated at that time was the rise of mobile. That was before smartphones. And now with smartphones, it's essential to have that kind of functionality available. But that was a small effort that grew into a big effort. Bloomberg is a good example of how this is happening in industry. Similar to what Vice is doing, they're using our translation API. And one of the interesting things there is that they need to keep on top of news from many, many, many different parts of the world and be able to kind of gather that news. And so they're using this such that they can take in articles in many, many different languages and make it easy for their analysts to be able to see the articles in those languages. And so it really has a big impact, even though it's a small step. The second thing is starting with the business problem and then figuring out the machine learning after that. And one thing we've found is there are a lot of cool things that machine learning can do, but you need to figure out what is the business impact that it's going to have. Urban Outfitters is a great example of that, and you heard a little bit about this in the keynote. And one thing that impressed me about what they're doing is that they tied this in to their inventory models. And what they were looking for is trends in what types of things we're selling. And there are things that they could do in terms of trends based on different SKUs and based on different characteristics that they knew. But if you add vision to it, you can actually start to get more trends out of this. So for example, you can look at the neckline of different products and be able to have that as a variable that you can use in your analysis. You can look at the pattern or the color on that item and be able to figure things out based on that. And so they're able to actually really enhance their analysis and make their prediction of inventory a lot better as a result of this. And so it's taking something really cutting edge around image processing, but really making it be something that is it solves a very practical problem. The third advice we give to people is to integrate this into applications as much as possible, because ultimately the end user doesn't care if it's machine learning or AI or whatever it is. They look at the functionality. And I think Google Photos is my favorite example of this within Google, where within Google, with Google Photos, everyone now has better access to photos. You know, I think about my in-laws. They don't know much about artificial intelligence other than the fact that they know I work on it. But what they do know is now they no longer have to organize their photos. They can find every picture of their grandchildren on Malibu Beach without having to sit there and organize every single photo that's there. It's just a functionality within the application that's powered by really, really powerful machine learning under the covers. A good example in industry where we're seeing this is with Marketo. So we've been working with Marketo to infuse AI technology into Marketo and give their marketers that are using this platform just benefits that they would see. And what it's doing is actually just making Marketo better. Better, for example, for people to predict what's the next action that they should take, or be able to analyze their campaigns, but they don't have to know that machine learning is what's there under the cover. The fourth thing is that machine learning can open you up to new interaction paradigms that weren't available to you before. Google Assistant is a great example for us. And a couple of things that probably seem obvious but are really impactful is that now with Google Assistant, we're seeing the mix of types of searches that people are doing on Google change drastically. So we're seeing more people, for example, go from keyword search more towards asking questions and having commands. on Google search. And these are things that you could probably have done by typing this into the Google search bar, but people aren't really trained to do that. But with voice, it's much more natural to ask a question or do a command. And so that has opened us up to a whole range of new interaction. We're seeing this with our customers as well, too. So Ubisoft is a game developer, and they're using Dialogflow Enterprise to have a chat interaction and a voice interaction with their customers and be able to develop a much stronger bond with their customers. We're seeing a lot of people use voice as a navigation paradigm. So one of the things we've seen is people that have realized they have mobile apps where the mobile app is very, very complicated, and there's a lot of functionality that their users never find. They can use voice or chat as a way for people to actually navigate the app and find the things that they want without having to kind of click through multiple menus to be able to get to what they want. And the last thing is that you should be thinking big. Even though it's daunting, you should be thinking big, because AI is going to be a revolutionary technology. It's going to be the kind of thing that's going to transform all of our businesses, much like the internet transformed all of our businesses 20 or 25 years ago. But you can also think about it in bite-sized chunks. And I'll share a personal story with you. I used to work on self-driving cars in the 1990s. My first job in college was at Lockheed Martin, working on self-driving cars. And we were part of a consortium of universities and government agencies that were all working on this together. And we were thinking about it in a very big scale, which was, how do we build self-driving cars, but then how do we have, for example, dedicated lanes for these cars on the freeway? How do we have central control centers that can help guide traffic and eliminate traffic as a result of that, and pipe that into in-dash maps? All things that didn't exist at that time. We got to a great proof of concept, and then everything fizzled from there. None of that technology really then has come to fruition until now. And we're seeing some of the things come back. But what was interesting is over the subsequent 20 years, we started to see parts of what we built come to fruition. So the first thing was that all of a sudden most cars have maps in Dash. Secondly, people started to have navigation in there, and so they can start to navigate around traffic. Third, you started to see levels of automation, things like automated cruise control or lane keeping that's part of there. And fourth, you now start to see automated cars that don't have to rely on infrastructure. And so by taking it in bits, almost every car out there has some element of what we had back there. Now, this can apply to a lot of things. So for example, in retail, we're seeing a lot of customers want to build autonomous stores. And that is an amazing vision to get to. But what's interesting is that you can take steps along the way that can get you to really interesting and really impactful parts that give you a step along the way. So for example, shelf outs is a huge problem in retail. Customer comes up to a shelf and the product is not there. They're probably not going to wait for you to refill it and buy it. They're just going to go to another store. So what if you have a camera trained on the shelf to be able to figure out if a piece of merchandise is there or not? It's actually something that it's not a trivial problem, but a relatively easy problem to solve, and something that people can get started with quickly, but then it can move towards more autonomous stores down the line. And so we're working with customers to really kind of take these big problems and these big visions, figure out what that big vision is, and then get it to bite-sized chunks. So with that, really, we're just at the very beginning, and we're going to rely on all of you as customers to try to help us figure out how this is going to impact our business. As partners, we're going to be able to use our technologies and be able to address problems that we never would have imagined. And so we're looking forward to working with you and innovating with you. Thank you. We really appreciate it. I think